Average speed is not the same as constant speed. We already know that average speed, written v-bar, equals total distance traveled divided by total elapsed time, delta s divided by delta t. But this creates an important trap. If a car has an average speed of 60 km per hour, it is easy to imagine that the car traveled at exactly 60 km per hour the entire time. That does not have to be true. Average speed does not describe every moment. It replaces the complete motion with one representative number. Imagine a journey of 120 kilometers that lasts 2 hours. The average speed is 120 kilometers divided by 2 hours, which equals 60 kilometers per hour. There are many ways to produce that same average. The car could travel 60 kilometers during the first hour and 60 kilometers during the second hour. In that case, it really could move at a constant speed of 60 kilometers per hour. But the car could instead travel 40 kilometers during the first hour and 80 kilometers during the second hour. The total is still 120 kilometers in 2 hours, so the average speed is still 60 kilometers per hour, even though the distance covered during the 2 hours was not the same. The car could even wait in traffic for part of the journey and then move faster. Average speed still asks one question: if the entire distance were spread evenly across the entire time, how many kilometers would correspond to 1 hour? That is why average speed is not the same as constant speed. Constant speed means that an object covers equal distances during equal time intervals. For example, suppose an object covers 5 meters during every second. In the first second it covers 5 meters. In the second second it covers another 5 meters. In the third second it covers another 5 meters, and in the fourth second it again covers 5 meters. The rhythm of motion does not change. The speed is constantly 5 meters per second. Now compare that with non-uniform motion. During 4 consecutive seconds, an object might cover 2 meters, then 7 meters, then 4 meters, then 9 meters. The distance per second changes, so the speed is not constant. Yet the total distance is 22 meters in 4 seconds, and the average speed for the complete interval is 5.5 meters per second. Average speed is like leveling out an uneven motion in our minds. 4 unequal pieces of 2, 7, 4, and 9 meters can be replaced by 4 equal pieces of 5.5 meters. The total distance remains 22 meters, and the total time remains 4 seconds. We are not claiming that the object actually moved 5.5 meters in every second. We are constructing a uniform replacement that covers the same total distance in the same total time. This is why average speed remembers only total distance and total time. It does not preserve each acceleration, slowdown, or stop. We always calculate it from the complete distance and the complete elapsed time, v-bar equals delta s divided by delta t. We must not automatically take the ordinary arithmetic mean of 2 speeds. Consider a car that covers the first 20 kilometers at 60 kilometers per hour and the next 20 kilometers at 80 kilometers per hour. It is tempting to add 60 and 80 and divide by 2, giving 70 kilometers per hour. But that is not the average speed of the whole journey. The two distances are equal, but the times are not. The first section takes 20 divided by 60 hours, which is 1/3 of an hour. The second section takes 20 divided by 80 hours, which is 1/4 of an hour. The total distance is 40 kilometers, and the total time is 1/3 plus 1/4 of an hour. Dividing 40 by that total time gives 480 divided by 7, or about 68.6 kilometers per hour, not 70. The slower section takes more time, so it influences the whole trip average more strongly. The correct method always begins with total distance and total time. When a journey has several sections, calculate the time for each section, add those times, and only then divide the total distance by the total time. There is one more important consequence. An instantaneous speed during a journey can be greater than the average speed. If a car waits in traffic for 10 minutes and later travels at 90 km per hour, its average speed for the complete journey can be less than 90 km per hour. During the stop, its speed is 0, and that stop time is part of the total elapsed time. So average speed is not the greatest speed, not the speed at every moment, and not necessarily the ordinary mean of several speed readings. It is one number that represents the complete motion through total distance and total time. Physically, average speed is the constant speed an object would need in order to cover the same total distance in the same total time as the real, possibly non-uniform motion. If this explanation helped, please like the video, subscribe to the channel, and leave your physics question in the comments. We will do our best to answer it.